Now on to section 2, which is really similar to section 1, except for now that we are dealing with variables. So for example, we want to simplify, and we're going to assume that the variable represents a positive real number, and our example is 2x times the square root of 80x minus the square root of 20x cubed. So I know in this example we have to somehow combine these. So our goal is to make them like radicals. So the first thing we're going to check is, does it have the same index? So they're both square roots. Since there's no numbers that are shown, what does that tell us? That tells us that the index is 2. Right? Since they both have the same index, then we can somehow change this, or hopefully get the same radicand. So in this case, the radicand is 80x and then 20x cubed. So let's simplify what's under there. So for the square root of 80x, for 80, I'm going to look at the first number that is less than 80, which is 64. 64 does not go into 80 nicely, so then we're going to look at 49. 49 also doesn't go into 80 nicely. And then for 36, 80 divided by 36 is not doesn't go in there nicely either. 25, no, but 16, if we divided 80 and 16, it would be 5. So this can become 16 times 5. Right. Yesterday, what I did is I separated the variable and its coefficient, but today I'll keep the variable in there. Right. So my main goal is to get perfect squares. Just find the perfect square under the radical instead of separating it. And so I'm looking at x. X is 1, and what does that mean? X is as simplified as it can get because 1 is less than our index. Right? So now let's look at 20x cubed. Right? So same process. I'm going to look at the first perfect square that is smaller than 20, which is 16 in our case, but 20 divided by 16 doesn't go there nicely. Then there's 9, doesn't go in there nicely either, and then there's 4. So for us, 4 times 5 is equal to 20. Okay? And then we're going to look at x cubed now. So x cubed, so the exponent is 3, and since our index is 2, what does that mean? So 3 is bigger than 2, so that means that our x can be simplified. So there's a perfect square in there. So when I look at x cubed, I'm going to look at the I'm going to look at the exponent, which is 3, and I'm going to divide it by the index, which is 2. So it goes in there. 2 goes into 3 once, and I have a remainder of 1. So what does that mean? I can rewrite this as x squared times x. Okay. Let me erase this to get some room. Right. So now let's continue. So we have 2x, and then for 16 times 5x, I'm going to rewrite it. So this is the square root of 16 times the square root of 5x. And then over here, I'm going to gather the perfect squares and then the non-perfect squares on the other side. So in this case, the 4 and the x squared, these are our perfect squares. So I'm going to put it as 4x squared, and then whatever is left, which is 5x. Right? So now, for 16, the square root of 16 is 4, because 4 squared is 16. And then square root of 5x, this is as simplified as it can get. X had the exponent's 1, which is less than the index. And 5, there's no perfect square that can go into 5. Right? And then 4x squared, what is that? This is 2x. So 2x times 2x is 4x squared, so we know that's correct. And then again, 5x. Right? So before we subtract these, we have to do this. So 2x times 4, that is 8x. And then 5x minus 2x, square root of 5x. Right. So in this case, this is a little different because before we just had numbers. So I look over here, so they both have this, so these are like radicals because it's square root of 5x, right? But in this case, we also have x. So, but because both of these have x's, we can combine it. Why? Because since they both have an x, square root of 5x in common, we can take that out, and I'll be left with 8 minus 2. And this will give us 6x times the square root of 5x. But how about, so for example, I'll change the color so we know that we're talking about something else. If I had ax squared times the square root of 5x minus 2x square root of 5x, this, we could not do anything about it, right? Because if I took out that x, because they have the x square root of 5x in common, and then I'm left with ax minus 2. And then if I cover the left part, and I look at 8x minus 2, were we ever able to combine it? No, right? So the same things apply here. So this would have been, this would have been our answer.